Assalamualaikum and hi. Today my friend and I has been given a task to talk about machine condition and fault diagnosis about gear for our assignment for subject vibration analysis and monitoring BMMM3583. First of all, I would like to introduce myself. My name is Zulfikar Hakimi bin Zulkifli, and my other team members is Ahmad Syamil bin Ahmad Kamarul Helmi, Muhammad Aminuddin bin Daud, and last is Dayang Nuhafiza binti Awan Khalid.
Assalamualaikum, my name is Dayang Nuhafiza binti Awan Khalid from BMMM 1/2. For introduction, the advent of digital technology and advancement in sensor technology have revolutionized machine condition monitoring and fault diagnosis of gear. Machine condition monitoring and fault diagnosis of gear are based on several fundamental theories and principles. There are some theory of vibration analysis, which is fundamental principle used in gear fault diagnosis. It is based on the understanding that faulty gears generate characteristic vibration frequency due to factors such as gear meshing, tooth wear, and misalignment. By analyzing the frequency spectrum of vibration signals, fault frequency and patterns can be identified, providing insights into gear health. Definition of machine condition monitoring and fault diagnostic can be defined as the field of technical activity in which selected physical parameters associated with machinery operation are observed for the purpose of determining machine health. Condition monitoring is a process of monitoring the operation parameters of electromechanical system. By monitoring the change of parameters and analyzing the physical relationship between parameters and fault, the diagnosis and the prediction of fault can be realized in a timely manner.
My name is Zulfikar Hakimi bin Zulkifli. My metric number is B0920102928. Today I would like to talk about the advantage and disadvantage of machine condition monitoring and fault diagnosis. First of all, as we all know, everything that we do, there must be a advantage and disadvantage. So first of all, I would like to share to you about the advantage that we can get. First of all, it will increase the machine availability and reliability. Why we say that is because by continuously monitoring the conditions of gear, potential failure can be detected early, allowing for timely maintenance or repair action to be taken. This leads to increased machine availability and reliability as the risk of the unexpected breakdown is minimized. Next, for the second advantage is to improve the operating efficiency. By monitoring gear condition, enable the identification of performance degradation or efficiency losses. By addressing this issue promptly, the operating efficiency of the machine can be improved, leading to the energy saving and optimize the production process. For the third advantage is to improve the risk management. When we talk about the risk management, we can relate it to less downtime. Early detection of gear fault allow for proactive maintenance planning, reducing the risk of unplanned downtime. This will improve the risk management by minimizing production disruption or associated financial loss. And the last advantage I would like to share is the reduce the maintenance cost. When we say about the maintenance cost, we must think about the better planning to reduce the maintenance cost. First of all, we can, by using the condition-based maintenance, allow for better planning and optimizations of maintenance activities. Instead of optimization of maintenance activity, instead of conducting maintenance based on fixed schedule, maintenance can be scheduled based on the actual conditions of the gear. This leads to reduce the maintenance cost by eliminating unnecessary tasks and focusing resources where they are truly needed. Next, the disadvantage that we can get from the machine condition monitoring and fault diagnosis is firstly is the operational cost. The operational cost implementing and running a comprehensive machine condition monitoring program can involve expenses related to acquiring monitoring equipment, software and maintenance. Additionally, there may be ongoing costs associated with data collection, analysis and reporting. For the second disadvantage is skilled personnel needed. Effective machine condition monitoring and fault diagnosis require trained and experienced personnel who can properly interpret monitoring data, perform analysis and make informed decisions. Hiring and retaining skilled personnel can be a challenge and may require investment in training and development program. For the third disadvantage is strong management commitment is needed. Successfully implementing and maintaining a machine condition monitoring program requires strong commitment and support from the management. This includes allocating resources, providing necessary funding, and promoting a culture of proactive maintenance and continuous improvement. The last disadvantage that we can get is the significant rise in time to collect machine history. To establish a reliable baseline and accurately identify fault condition, a significant amount of time may be required to collect the machine history and trends. This period allows for the accumulations of sufficient data to establish normal operating conditions and detect
Hi,
the anomalies
my
or
name Muhammad
deviations.
So my part is the importance of gear. First, the importance of gear is to minimizing downtime. Gear failure can result in costly and unplanned downtime, leading to production losses and delays. By continuously monitoring gear condition and diagnosis fault, potential issue can be identified in advance, allowing for proactive maintenance and reducing the risk of unexpected failure. This minimizes downtime and ensure uninterrupted operation of machinery. Second, the important is cost can be optimization. Early detection of gear fault enable timely repairs or replacement, preventing minor issue from escalating into major failure that require extensive repairs or complete gear replacement. By addressing fault at any early stage, maintenance costs can be minimized and resources can be allocated efficiently. Third, can improve in safety. Faulty gear can pose serious safety risks, particularly in critical applications such as aerospace, automotive, and heavy machinery. By monitoring gear condition and promptly diagnosing fault, potential hazard can be identified and mitigated, ensuring the safety of operators and preventing accident or catastrophic failure. And lastly, extend equipment lifespan. So, regular monitoring and fault diagnosis can help identify and rectify issues that contribute to accelerated gear wear or damage. By addressing this problem in a timely manner, the lifespan of gear can be extended, maximizing the return on investment and reducing the frequency of equipment replacement.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syamil bin Ahmad Kamar Helmi. So today I will explain about how to measure gear faulties. There are 4 ways to measure gear faulties. So the first one is by vibration analysis. Vibration sensor or accelerometer are used to measure the vibration signals generated by gears during the operation. These sensors are typically placed on or near the gear housing. The collected vibration data is analyzed to identify specific fault frequencies or harmonics and abnormal patterns associated with gear faults such as tooth wear, pitting or misalignment. So the second way is oil analysis. Regular oil sampling and analysis are conducted to assess the condition of the lubricating oil in gear systems. Various parameters are measured, including viscosity, particle count and the presence of contaminant. Abnormal metal particle or excessive wear debris in the oil can indicate gear damage or impending failure. The third way that we can use to measure gear faulties is by using thermography. Infrared thermography involves using thermal cameras to measure the temperature distribution on the gear surfaces during the operation. Variation in the temperature pattern can reveal abnormalities such as excessive friction, misalignment or gear tooth defect. So the last way that we can use is NDT, non-destructive test technique. NDT technique such as magnetic particle inspection, dye penetrant inspection or eddy current testing can be employed to detect surface crack, defect or material abnormalities in gears. This technique involves specialized equipment and procedure to evaluate the integrity of gear surfaces. So that's all from me. Thank you.
So, for the conclusion is, the diagnosis and prediction of fault can be done in a timely manner by monitoring the change of parameter and studying the physical relationship between parameter and fault. There are so many potential advantages of machine condition monitoring, such as it can increase machine availability, extended operational life, and improve safety. For the fault diagnosis, it provides the prerequisites for fault tolerance as well as reliability. Next, gear in a generator provide an excellent example of how machine must wear in during yearly use. The time waveform and frequency spectrum are the most often used technique in the industry. This approach makes us of graph as a reference to detect their fault. Next, the new gear will have defect that quickly worn away in the machine early life. Vibration level will become steady and only increase gradually later in the machine life as the gear wear out. This gradual increase in vibration level normal. Sudden change in vibration level at gear mesh frequency 2 times gear mesh frequency, especially decrease, are very significant. Therefore, a drop in a vibration level usually means decrease in stiffness, and that more of the transmission force are being absorbed due to bending of their gear teeth. Thank you.